Okay, here it is, the final section in what probably feels like the unending chapter 7, factoring polynomials completely. This is our extension. Our learning goal is to, goal, I will factor polynomials completely. So what that means is polynomials, exclamation point, because it's exciting. What that means is you're going to just use all of those methods that we've been talking about since the quiz to factor pretty much anything that's possible. Something to know, you can't always factor a polynomial. Until you are in Algebra 2 and you start talking about imaginary numbers and that sort of thing, some of these just won't be able to be factored. And even then, you might not necessarily be able to factor them. But you're going to need to at least know how to do the ones in this book, right? So to start off with factoring by grouping, you're going to notice right now this actually has 4 terms, not 3 terms. And one of them is a cubed term. So that should be a pretty big flashing red light right in your face that, hey, you're going to have to do something different here. It's a pretty good indication it's going to be factoring by grouping. Real quick, I'm going to look through and make sure I don't have a greatest common factor between all 4 terms. So instead, what I want to do is to break it into 2 binomials, or 2 pieces with 2 terms each. And those terms need to have something in common. So if I look here, x cubed and 3x squared, that has an x squared in common. If I look at this piece, 2x and 6, they have a 2 in common. So I'm grouping it into 2 binomials. Here, like I said, these have an x squared in common. If I pull an x squared out, I'm left with an x from this term and a 3 from this term. I'm going to keep that addition sign in there. And if I look at this guy, I said they had a 2 in common. I can pull the 2 out from 2x and be left with x, and a 2 from 6 would leave me with 3 because I'm dividing out that. Think about this for a second. If this were x squared times w plus 2 times w, they have that w in common. I could factor that out and I would be left with x squared plus 2. This is the same situation, except for instead of a w, they have this x plus 3 in common. So I'm actually going to factor this entire term out, or this entire grouping out. So I factor out an x plus 3, and remember up here when I was using w, I was left with x squared plus 2. Same thing here, I'm left with an x squared from this term, and I'm left with a 2 from over here. So this up here will actually factor to x plus 3 times x squared plus 2. And then if you look at this guy, even though that's an x squared, you actually can't factor this any further. We don't have any rules or anything that'll help us factor this. So this is the factorization of this original thing up here. So let's try another one, just to make sure we're on the right track. If I had x cubed minus 7 minus x squared plus 7x. If I want to use a similar method from up here, remember first I grouped into binomials that had something in common. When I look at here, x cubed and 7 don't have anything in common, but the x cubed and the x squared do, and the 7 and the 7x do. So I can use my commutative property to flip these two. So let's just change the order and make this x cubed minus x squared minus 7 plus 7x. So I just switched my order so I had 2 binomials that have a factor in common. X cubed and x squared have an x squared in common, and I'll be left with an x. When I divide out an x squared here, I'll be subtracting 1. Make sure you're paying attention to those positives and negatives. And then here, let's write this as adding a negative 7 for a second. I'm pulling out a 7. So what will be left is a negative 1 from here and an x from here. And when you look at those, you're like, oh, but this is x minus 1, this is negative 1 plus x. Let's use our commutative property again and switch those. So this has an x minus 1, and this is 7 times, because this is addition, I can do the commutative property, x plus negative 1 or x minus 1. So I had to do a little bit of trickery to see that these actually do have that x minus 1 factor in common. And then my next step would be to factor out x minus 1. So an x squared is left behind here, and a 7 is left behind here. So this factors up here, this guy, factors to x minus 1 times x squared plus 7. Okay, so like I said, factoring by grouping, you can always tell you're going to be using grouping because that's the only time you're going to have 4 terms. But continuing on with the factoring completely, if I had this, let's make that a 2x cubed minus 2x squared minus 12x. You might look at that and think, oh, there's a cubed term, I have to group. That's not quite what we want to do here, though. Instead, we're going to first find a greatest common factor. 2x cubed minus 2x squared minus 12x, what do all of these have in common? It's pretty obvious that they all have an x in common, but you'll see the coefficients also all have a 2 in common. So I'm going to factor out a 2x as my greatest common factor before I do anything else. When I pull out a 2x from 2x cubed, we're left with an x squared. 2x times x gives me 2x squared, and 2x times 6 will give me 12x. Notice that these were subtraction, so I kept them subtraction here. So now that I've pulled that 2x out, I'm left with x squared minus x minus 6. I can keep going from here. This is not factored all the way, but as I go, I don't want to forget about this 2x out front. So he's just going to hang out there the whole time. To factor this completely, I look at, well, I have a negative last term, so that tells me that when I have my parentheses, and that's an x, right? Those are both x's because I don't have a coefficient to my x squared term. It's going to tell me that one of these has a positive and one of these has a negative, because when they multiply together they give me a negative. My middle term is negative, so the greater factor is going to go with the negative sign. 6 comes from 1 and 6 and 2 and 3. So if I have, remember the greater one we said was negative, so that's either negative or that's negative. My middle term is negative 1. 1 and negative 6 make negative 5, so that's not it. So this is a 2 and a 3. We can multiply it out real quick in our head to make sure. X squared minus 3x plus 2x is negative 1x minus 6. This can't be factored any further. This can't be factored any further. So the factorization of this up here is 2x times x plus 2 times x minus 3. So really the last part of this is just finishing off these more complicated ones and making sure they're factored as far as you can go. So it's using all of the other sections to finish the factoring. So there are a lot of practice problems, and you can go through these. I am going to show you one that might be a little different than what you've seen before. X squared minus 3x plus 5. Nothing in common between those terms. So what I have to do is this has an x, so this will be x times something, this will be x times something. The last term is positive, but the middle is negative, so these have to be negatives. And then I think about the factors of 5, 1 and 5. Those are the only factors of 5. So I would think that it's x minus 1 times x minus 5. I want to multiply those out and make sure it works. And this is a pretty good reason why you always want to multiply when you're done to make sure that you get what you're supposed to have. X times x is x squared. Inside would be negative x. Outside would be, oh, I did those backwards, but it would be negative 5x, and last would be plus 5. Look at what we have here, x squared minus 6x plus 5, but I wanted minus 3x. This was my only possible pair, and I did not get what I was supposed to get. So what that tells me, this up here can't be factored, at least not using real numbers. This actually will end up having imaginary roots. So every once in a while you're going to get one that can't be factored, which is why you should always multiply out what you think the answer is to make sure that it actually is the answer. So your homework, page 388 to 389, and there are 1 through 18. So 18 problems just along the bottoms of those 2 pages. So good luck with those, guys.